Hey everyone, another day, another LeetCode problem. So this is the first problem in my graphs playlist. So this is LeetCode 200, that is number of islands. So this is a very basic fundamental graph problem that will probably help you understand like BFS, DFS. So let's just go to the problem statement. You're given an mn two-dimensional binary grid, which represents a map where ones correspond to land and zeros correspond to water, and we need to return the number of islands. So yeah, what this basically tells us is an island is land which is connected to each other in all four directions. So they want us to give the number of islands. So if we just look at this first example over here, we look at all those directions to the right of this one, they're all connected. Then the left of this is connected. This one over here is connected. Then we go down, these are connected. So if we look at that in all four directions, starting from the first one over there, we just have one island. So that's one. And the second one over here is actually 3 islands. So I'm just gonna hop over to my iPad so we can get a better look. So yeah, if I connect and if I connect in all four directions over here, I get one island. I get another island over here and another island over here. So basically, I want to traverse through the graph and count the number of islands that I have. And anytime that I find a piece of land, I want to see what other piece of land is connected to this land. And let me go and explore all of the land that's actually connected. And once that is ended, you probably just swim over to the next island and you start from there. You kind of conquer all of that. And then you keep doing that for as long as your entire map or your graph is. So in this case, we're actually given like a binary matrix, right? So we have ones or zeros. And so as we spoke in the last lecture, for traversal, we can either use a BFS or a DFS. So in this, I'm going to prefer a BFS and a DFS actually. So let's just see how that's going to work. As we saw in a DFS, you're going to have something that's like a visited set for all the coordinates that you visited, because you don't want to repeat the same coordinate and go in like a cycle or an unending loop. So we'll have that, and then we'll have our number of islands. Let's say I start from this coordinate 0, 0. Okay, and what they've told us is that it has to be connected in the 4 directions, up, down, right, and left. So 0, 0, I'm going to go ahead and add that over here. So 0, 0 coordinate is already covered. I'll look to the different directions. This is out of bounds, not to be considered. And then I see 0, 1 is also a piece of land. 1, 0 is also a piece of land. And then because it's a DFS, the moment that I would go here, I would actually be looking at its neighbors. So I'd go here, and then I'd be adding 1, 1, and this would come here again. And once I do a DFS from here, I see that every valid piece of land, which is a neighbor, has actually already been added to visited. So yeah, that happens. And I had started a DFS from one point, and I was able to conquer all the land that was connected to that one point I started from. So right now my number of islands is 1. And we're going to do this from each single coordinate in our entire graph. So the next coordinate that I would go to by default would be this one. But then I see that it's already visited, so it's not something that I can conquer. Not going to work. And I'll come to this position, and this is a 0, which is invalid. So I'll go here, 0 invalid, 0 invalid. I'll come to this one, already conquered. This already conquered. Again, 0, 0, 0. Not valid. Then I'll come to this one over here. So that is 2, 2. We see that that's a valid piece of land. And because it has a 1, it's land. Then I look in the 4 directions beside it, and I don't see any other land. It's all zeros. So I come back to the call from where I actually made this DFS call, and I go ahead and increase this to 2. Then 0, 0, all are invalid until I come here. So this is actually 3, 3. So if we look at 3, 3, it's land again. Then I'll look in different directions. This is out of bounds, but I look to the right and I find another position. So this is actually 3, 4, and that. And I come back here and make this 3. And at this point, I would come to this position, but I see that it's already been visited, so I don't need to visit it again. And then I would return 3 as the answer. So that's the number of islands that I have. And if we go ahead and look here, yes, it is 3, and that was the same example. So yeah, we can we can actually go ahead and do a BFS for this, and DFS, sorry. Yeah, and you can also go ahead and do a BFS for this. Implementation would be different, but ideally you just traverse the whole thing and you conquer everything and go. So if we look at the time complexity here, as I saw, I was going through every individual coordinate here. So this would be m into n. And then for every coordinate inside my DFS function, I'm looking in 4 directions. And because we're using a visited set, I know that I'm not going to be repeating. I'm not going to be repeating coordinates again and then kind of going in a loop. So I can just do m into n times 4, and then 4 is technically a constant, so we drop that. And the space complexity. So what are we doing here? We're going to be, at most, we're going to add all the coordinates to our visited set. So again, that would be m times n coordinates, and then islands is just a constant. So yeah, this is our time and this is our space. So yeah, this is actually the optimal solution, and you can go ahead and just write out the code. Okay, so what I like to do is I like defining like what we have, rows, columns. So that's the length of our grid and the length of the first row. So we have that, and we can also write like this condition: if grid doesn't even exist, then we just return 0 by default. We don't want to go through everything. Let's go ahead and consider islands 0, and we'll write a DFS function over here. Let's call it conquer island or something, and to that I'm going to be giving the starting coordinates, so R and C. One thing I forgot over here is before this we need a visited set. Okay, so the first thing that I mentioned, once we come here, we're going to add that. So visited, I'll spell it right. Okay, visited dot add R comma C. All right, and once we visit it, we want to go through all 4 directions to kind of visit those, right? So we'll do that. We can probably write that. We'll write direction. So we know the coordinates are 1, 0, 0, 1, minus 1, 0, and 0, minus 1. All right, so we're going to look through like the neighbors by using this, right? So for these values and directions, I can take like a row and a column is equal to equals DC. Okay, now I want to check if these are actually valid or they're out of bounds. So I need to make that check. So I can say if it's within the bounds of rows and 0 columns, and also it has to be a 1. So the grid of row and column should be a land, and row and column is not already visited, not in visited. So are these, yeah, that's pretty much all the conditions that we should have. Then we go ahead and to conquer island for that neighboring piece of land. So for row, comma, column, that would again come here. It would add this. It would do all of that. So if at any point that it's already visited, it just comes back, right? So at the end of this, I should have conquered that specific connected island. Okay, so this is the part where we call it. So I could do for R and range rows. C and range columns. I need to check if RC not been visited, and it has to be land. So grid of RC is equal to land to start with. Then I'm going to go ahead and do this conquer island of RC, and I've conquered it. So I come back and islands is incremented. So yeah, at the end of this, I can just do a return islands. I hope this is correct and that I haven't really made any typos, but let's just, okay, I normally spell it wrong. Visited. Okay, it works. So as we discussed, the time taken for this is O of M into N into 4. You can drop the 4. So M into N. And the space is also equal to M into N. So this is for the visited set, but we're also doing recursion because DFS is basically recursion, and we have our recursive stack. So that's another M times N. So it's actually 2 M into N, but since we drop constants for simplicity, it's just M into N. So yes, this is the solution, and I hope you guys understood. So yeah, happy coding, everybody.